There are many predators in the Chesapeake Bay, including birds and fish, but one of the most common and aggressive predators in the bay is the blue crab. Blue crabs eat anything they come across, but most of the time they eat clams, mussels, and oysters. I am conducting an experiment to see how blue crab feeding behavior changes depending on the identity of its prey, the habitat where the prey is found, and certain changes that are expected to occur because of climate change. Crabs are allowed to feed in tanks with clams, oysters, or mussels. I watch the video and calculate how long it takes the crab to find its prey, and how long it takes the crab to eat its prey. A crab is foraging, or looking for food, when it is probing the sand with its feet. These have special sensors to detect movement. When a crab finds prey and holds it in its claws, that's when the encounter starts. Sometimes it can take a crab a very long time to eat a clam, especially when the clam has a thick shell. Even though mussels are very easy to find, eating a mussel is still not very easy because they live in clumps. Different types of clams, mussels, and oysters face different threats. Mussels, oysters, and armored clams all face ocean acidification, which is expected to thin their shells, and, for mussels, weaken their attachment to the clump. Will ocean acidification result in more mussels, oysters, and clams being consumed by crabs? We don't know, but this study might help us decide. If a clam doesn't have armor, it must hide. Living under a structured habitat, like seagrass, can make avoiding predators easier. But in the Chesapeake Bay, seagrass is disappearing, largely due to warming waters. Certain clam species that rely on avoiding predators are also disappearing, like the softshell clam. Does the softshell clam rely on seagrass for protection? This study can help answer that question.